Factorisation.com.
Next question. Use Euclid's division lemma. Euclid's division lemma to show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. This is our question. We have to show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. So, first of all, we are assuming let a be any positive integer. Let a be any positive integer which is of the form 3q plus 1 or 3q plus 2. 3q plus 1 or 3q plus 2. We are assuming any positive integer, a be any positive integer which is of the form 3q plus 1 or 3q plus 2. Case 1, first case. Let a is equal to 3q. Squaring. We have to show that the square of any positive integer. Therefore, a square is equal to 3q the whole square. That means, that is, a square is equal to 9q square. We can split this 9q square as, that is, a square is equal to 3 into 3q square. 3 into 3q square which give 9q square. That is, a square is equal to 3 into m, where m is some integer and m is equal to 3q square. That is, we are assuming the value of 3q square to be another integer m, so that a square is equal to 3m. Here a square is equal to 3 into 3q square, and we are assuming this 3q square to be another integer m, and therefore the value of a square reduces to 3m. That is, a square is equal to 3m. That is, a square is equal to 3m. That means the square of the positive integer a is equal to 3m. This is the first case. So, we got the answer of the first case as 3m. Now, we are taking the second case, case 2. That means a is equal to 3q plus 1. Let a is equal to 3q plus 1. Therefore, a square is equal to 3q plus 1 the whole square. A square is equal to 3q plus 1 the whole square, and here we have to expand 3q plus 1 the whole square using the identity a plus b the whole square. That is, a square is equal to 3q the whole square plus 2 into 3q into 1 plus 1 square, a square plus 2ab plus b square, which is equal to, that is, a square is equal to 9q square. The square of 3q the whole square is equal to 9q square plus 2 into 3q into 1 which is equal to 6q, then plus 1 square is 1 itself. We are taking 3 as a common factor from the first two terms. Therefore, a square is equal to 3 into 3q square plus 2q. A square is equal to 3 into 3q square which is equal to 9q square, 3 into 2q which is equal to 6q, then plus 1 is here. Now we are assuming this 3q square plus 2q to be another integer, namely m. That is, a square is equal to 3m plus 1, where m is some integer, and m is equal to 3q square plus 2q. Therefore, here also we are getting a square to be 3m plus 1. That is, we have proved the second result. That is, the square of any positive integer is of the form 3m plus 1. Now, we are taking the third case, case 3. That is, a is equal to 3q plus 2. 3q plus 2. Therefore, a square is equal to 3q plus 2 the whole square, and here also we have to expand 3q plus 2 the whole square using the identity a plus b the whole square. That is, 3q plus 2 the whole square is equal to 3q the whole square plus 2 into 3q into 2 plus 2 square, a square plus 2ab plus b square. Now a square becomes, a square is equal to, that is, a square is equal to 9q square plus 2 into 3, 6 into 2, 12q, then plus 2 square is equal to 4. Here also we are taking 3 as a common factor from the first two terms. That is, a square is equal to, taking 3 as a common factor, we are getting 3 into 3q square plus 4q, then plus, we can split this 4 as 3 plus 1. This is equal to 9q square plus 12q plus 3 plus 1. We are splitting this 4 as 3 plus 1. Now we are taking 3 as a common factor from both the 3 terms. From the first 3 terms, we are taking 3 as a common factor. Then 4q plus 1, then plus 1. 3 into 3q square, which is equal to 9q square. 3 into 4q, which is equal to 12q. And 3 into 1 is equal to 3 itself. Then plus 1 is there. Now we are assuming 3q square plus 4q plus 1, the terms within the bracket, to be another integer, namely m. That is, a square is equal to 3m plus 1 for some integer, for another integer m. For another integer m, where m is equal to 3q square plus 4q plus 1. We are taking the terms inside the bracket, that is 3 square plus 3q square plus 4q plus 1 as m, where m is equal to 3q square plus 4q plus 1. That is a square. That is, here also a square is equal to 3m plus 1. That is, we are obtaining the result. That is, the square of any positive integer is of either of the form 3m or 3m plus 1. We have proved. That is the square of any positive integer. That is, the square of any positive integer is either of the form 3m, is either of the form 3m or 3m plus 1 for some integer m. Some integer m. Hence proved the result. Hence proved the result. See, this is an important question, so note it as an important question and study this very well. Okay.